We're going to look at page 4 and 5 of the Metric System and Scientific Information. Here we are on page 4, and we're estimating sizes and units on 56 through 60. Your homework is the next section, 61 through 66. We're going to look at 54 through 60, that's A through G. And I'm going to expand this so that I can write on it a little more efficiently. Alright, a raisin has a mass of about, so we're talking about mass, so we're talking about grams and kilograms. That would be 1 gram, or in SI units, which is kilograms, we could say it's 0.001 kilograms. A nickel has a mass of about 5 grams. So these are units that you can get used to using so that you can get a feel for them internally and be able to approximate. An actual nickel is about 5.1 grams, but this is 0.005 kilograms. The width of a paper clip, that's about 1 centimeter, which is the same as about 0.01 meters. But 1 centimeter is a good way to remember that. 2.2 pounds. That's almost the conversion for pounds to kilograms. A kilogram is 2.2 pounds. Candy bar has a length of about what? Well, I guess it depends on the candy bar. But most candy bars are about 15 centimeters. That's about half a foot, about 6 inches. A yard is 3 inches shorter than what? Than 1 meter. So when you're thinking about meters, 1 yard and 1 meter are very close to the same thing. So 100 meters is a little bit longer than a football field. Just like a football field is 100 yards, 100 meters is a little bit longer. And G here, a little more than half a mile, is 1 kilometer. Okay, or 1,000 meters. Now let's move on down. Of course, these right here are homework problems, so I'll leave you to do them. And on the number line, on this number line, if you wanted to practice, this is not a homework problem, but 10 to the 0, it says label each power of 10 with the appropriate prefix. Well, right here, there is no prefix for 10 to the 0. This would be whatever the base unit is. So if you were talking about meters, that would be 1 meter. If you were talking about mass, it would be 1 kilogram. And as we go on through here, we have deca, hecta, or hecto, kilo, an L in there. And then we go on to mega and giga. That's an A. On this side we have deci. Oops, that's a E, C-I, deci. Centi, like a cent. It's where we get our dollars and cents. Here we have milli. And then as we go on down, we start, of course, right here, you notice 10 to the 0, -1, -2, -3. There are no prefixes for -4 and -5. We begin right here, skipping by thousands, or 1,000ths when we're going to the negative side. And 1,000, or 1/1000th of a millimeter is a micrometer. That's abbreviated with the small little thing that looks like a U, the little Greek letter. Then after that, we have nano. And as we go on down 1,000 below that, we have pico. On the opposite side over here, above mega, giga, and then we have tera. And these might be common for These might be known because of computers now, as in kilobytes, megabytes, gigabytes, terabytes, and so on. Now let's go down and look at these conversion factors. Or I should call these unit conversions, really. The first one says how many seconds are in a year. Let's move that like that. Okay. So, in order to figure out how many seconds there are in a year, it says first assume that there are 365 days in a year. So how many seconds are in a year? This is our given, 1 year. So we're going to start with 1 year. And we need to convert that into seconds. So I'm going to do this. Now it says using the factor label method. You know this as dimensional analysis. They're the same thing. The first thing I need to do is find something smaller than a year. It says assume 365 days in a year, so let's convert years to days. In order to get rid of years, I'm going to say that there is 1 year in 365 days. It's the same thing as 365 days in a year. So, I've now canceled my years, and my number is now 365 days. Next, I'm going to say that there are 24 hours in 1 day, and 60 minutes in 1 hour. Now I can cancel my days, cancels with days, my hours cancels with hours, and I'm left with the units of minutes. So I'm almost there. Continue this just a little bit more, and I see that there are 60 seconds. I really should put in S for seconds in 1 minute. Minutes cancel with minutes, and it leaves us with only 1 unit, seconds, which is what they were asking us for in the beginning. I'm going to move this on just a little more, and I end up with a really big number. That number is 31,536,000. Because this is a really big number, it's a great place to use scientific notation. So I need to take the decimal point and get it to this spot. So I need to move it 1, 2, 3, hang on, 1, 2, 3, 4, 5, 6, 7 places to the left. So I'm going to have this number, 3.1536 times 10 to the 7th, and my units here are seconds, or when they say seconds per year, seconds in a year, seconds per year. And again, the actual abbreviation for seconds is just S. I'm in the habit of writing SEC for seconds because my S's look so much like 5s. If you have prettier handwriting, you don't need to do that. So, B, convert 28 kilometers into centimeters. So we'll start with our given 28 kilometers. Now we can go straight to centimeters with our stair-step type table and just count the number of steps. But it would help us to do this in 2 steps because we know each part of the step. We know that there are 1,000 meters in 1 kilometer. We also know that there are 100 centimeters in every meter. So our kilometers cancels with kilometers, our meters cancels with meters, and it leaves us with units of centimeters, which is just exactly what they asked for, so we know we must have done it right. When we multiply all of this out, we get a large number again, which is, it's 28. Let's see if we can undo that. well, I guess not. 2800,000, and the units are centimeters. If I convert this into scientific notation, I can put my decimal point right there. I need to move 1, 2, 3, 4, 5, 6 places to the left. So I end up with 2.8 times 10 to the 6th centimeters. And that would be our answer. Next, we're going to convert 50 grams to kilograms. So our given, 50 grams. And we know that there are 1,000 kilograms in a gram, or pardon me, 1,000 grams in a kilogram. We need to figure out where to put it. What we're trying to do is get rid of grams, because that's the number we have here. So we're going to put our 1,000 grams on the bottom. There are 1,000 grams in 1 kilogram. You don't have to write the 1. So we end up with 50 divided by 1,000, and that gives us 0.05 kilograms. The units are kilograms because this grams here cancels with this grams here. It leaves us with that. If we wanted to write this in scientific notation, we have to move the decimal point over 2 places, and we end up with 5 times 10 to the minus 2 kilograms. The next one, we convert 45 kilograms into milligrams. So we're going from one side of the stair step, the large side, to the small side. We'll start with our given 45 kilograms. And we're going to stop along the way at our base unit. We're going to do it the same way that we did before. We're going to say that there are 1,000 grams in 1 kilogram, and that way we can cancel kilograms. Look at how this unit conversion factor and this one are the same, but upside down. In the case in C up here, we're trying to get rid of grams and leave kilograms behind. Here, we're trying to get rid of kilograms and leave grams behind. So we've just flipped the conversion factor upside down. Now let's get rid of these grams and go to milligrams. There are 1,000 milligrams in every gram. So now we can cancel our grams, and it leaves us the units of milligrams. So our answer is 45 times 1,000 times 1,000. So 45 times 1,000, just add 3 zeros, times 1,000, that's 45 million milligrams. Again, this is a good number to convert to scientific notation if we had to do it in milligrams anyway. Of course, kilograms is the obvious choice for units to use because it's a small number that we can get a handle on. Remember, each kilogram is about 2.2 pounds, so this is about 100 pounds. But 45 million kilograms is kind of an unmanageable number. So let's convert it to scientific notation. We'll start with our assumed decimal point and count 1, 2, 3, 4, 5, 6, 7, so that our decimal point will be right there. We end up with 4.5 times 10 to the 7th milligrams. E and F are left for you to solve. These are homework problems. So I'll skip those and we'll move on to the next page, work assignment. And these are the just for fun questions right here at the top. We're going to answer these just for fun questions by looking for the metric prefix that we would use. 10 to the 1 is deca. Well, with a K. Deca. So 10 to the 1 cards is a deck of cards, or a deck of cards for those of you who are a little slow on the uptake. 2 times 10 to the 2. Well, 10 to the 2 is hecto. So 2 hect, and I'll leave off the O with it. To heck with it. 2 times 10 to the 3 mockingbirds. 10 to the 3 is kilo. So to kilo mockingbird. You've read the book or seen the movie. 10 to the negative 3 is milli. So this is military. 10 to the 3 is kilo. Kilo Manjaro, or Mount Kilimanjaro. 10 to the minus 6. Okay, this one is outside of that 3 above and 3 below. The first one below, 10 to the 6, is represented by that little U symbol, which is micro. So 10 to the 6 phone is a micro phone. 10 to the 12th, much smaller number. After micro we have nano, and after nano we have pico. So this is a peekaboo. And 10 to the minus 2, that's centi. So this is something sentimental. All right. Those are all of the questions that you have for that are not assigned. The rest of these questions you need to go on and answer on your own. The last 3, this is a really rough conversion because you have feet, you have inches, and you have fractional inches. So you're going to have to convert your fractional inches into inches, and then your inches into feet, and then convert into dollars. Remember that they're looking for the price. So this right here, price per square yard, is a conversion factor. The conversion factor is dollars per yard squared or per square yard. So in order to get that answer, you're going to have to multiply that by the number of square yards so that they cancel and leave you with just dollars. I'd suggest that you solve for the number of square yards first and then multiply by the dollars per yard, per square yard, when you're done. That would be the easiest. But you're going to run into some difficulty because you have to first convert your fractional inches into inches and then your inches into fractional feet, because inches don't lend themselves to multiplication and addition along with feet when you're trying to figure out area. So you need to get them in a consistent set of units, feet in width and feet in length, so that you can get the area of square feet. And then after you have the area of square feet, you can convert feet squared into yards squared, because a yard is 3 feet on a side. So 3 feet times 3 feet is 1 square yard. How many square feet is that? Well, 9 square feet, or feet squared, is equal to 1 yard squared. So you've got quite a bit to do. After that, you'll do the same conversion right here, figuring out the square meters, and then multiplying that. You can do that with the train tracks if you want, but you end up with dollars per meter squared, and then meter squared cancels to give you the answer in dollars. Or you can have meter squared times dollars per square meter. Almost said square yard. That cancels and still gives you dollars. So really your price per square meter is what goes right there. When you're done with that, I hope you have the good sense to answer that you prefer the metric system, especially for doing physics problems, because you're going to find that that English system was way too difficult, and you're going to say, Mr. Friends, please never give us anything in the English system again. We prefer metric or SI. And that'd be a good answer. I hope this hasn't been too much trouble for you. So, good luck on doing the rest of them. If you have any trouble, please come on by and see me after school. Remember, Mondays, Wednesdays, and Fridays after school. I'm also here in the mornings for tutorials.